Hi, this is Krishna, and I'm presenting or like giving a demo of our project for this course, API design. And so we have around we are conducting a study on the impact of different like design rules, pattern and patterns, poor design practices, good design practices on the understandability and readability of APIs. So as a part of that, we'll have more context in our presentation. So as part of that, collected we have conducted a survey, and from the survey we have got this data. So we have if I give an example, so we have like for each pattern and pattern we have like a column that has like if one, then like respondents. So we have participants over here, and then we have for amorphous like participant 56 did not choose the correct option. That's why like 0. So compared to like 56, 57, 69 selected the correct one. So the participant number does not start with 1. That because like there are so many empty responses or like incomplete responses. So that's why like the numbers a little bit different. So in a similar way, we had around uh, along with the independent question, we have like two rating questions. One is understandable rating, and one is readability rating as well. And in the same way, we have around 28 questions for ratings and 28% for parent independence, 28 for understandable rating, and 28 for readability ratings. And we have also collected the time it took for participant to respond to each of those questions. And we have some demographic information over here that we use to analyze or generate our results that we use to answer our research questions. So this is our script that we are working on. So we first import all the libraries, and then we put the data. And if we see the data, so we have everything, and then we summarize the data a little bit with. So we have around like we had most of the responses were from Canada. That we were also in Canada, so we had some of the responses from Bangladesh, India, and then Ireland, Pakistan, and Sweden. And then we pretty much calculate the time actual understandability that and add it to the data frame, and we create a combined data frame with tau and the ratings that we had. Tau and ratings that can using this tau matrix and the ratings as combined data frame, we answer all the RQs. So let me run all the codes for RQ1. So if we run all the codes, then we will have some plots that will help us support our hypothesis. For RQ1, our question RQ1 was whether so which rule has an impact on the understandability of APIs. So we got some plots. So let me start from the beginning. So this is the distribution of the tau. Because tau is not distributed, so we went for non-parametric approach for hypothesis testing. So before that, let me explain. So this figure. So from this figure, we can say like most for patterns, like most of the like important patterns, like I think for all of them, like participants were most of, like highest number of participants were able to guess the correct answer. And similar thing also happened for mean time to answer. So like for most cases, it took more time to answer the question that were compiled with independent compared to patterns. And for tau, we can see like tau, the higher the tau is, the better. So for example, like the blue bars represent like patterns, and red bar represent anti-patterns. We can see like more almost all of the categories of pattern anti-pattern has like higher taus compared to anti-pattern. So in this way we can say that like anti-patterns are a little bit difficult to understand compared to patterns. In the same way we also use this like plots uh, to show the distribution of the tau, and in most of the cases the distribution like this mean tau for like this a tidy endpoints, like you can see the huge difference between patterns and anti-patterns, so that like it makes sense, like it's really easy to understand the tidy endpoints and compared to like amorphous endpoint, which is the corresponding pattern for anti-pattern for tidy endpoints. In the same way we had another plot for rest of the 8 pattern anti-patterns, and then we have this figure. So this figure generates like the effect size of this pattern anti-pattern rules on our understandability. So you can say like if like the effect size or the value of coherentity is less than 0.2 or something, which in that case like that is insignificant, but if it's like greater than 0.2 it's like significant. So in most of the cases like it's greater than 0.2, and for non-party endpoint or non-party endpoint is like 2.16, so it's like huge impact. So these design rules have huge impact on the understandability of APIs as per the Coins. And similarly we can just run the script for RQ2 and RQ3, and we would be able to see the rest of the figures, and we can just reuse them to. So I'll just run it for the 2. It will generate all the figures, and the same way I will select RQ3 and RQ3 and run it. Before that, like it also RQ2. So let me explain a little bit about RQ2. So RQ2, we're trying to figure out how. Okay, so for RQ2, we are trying to figure out like how the perceived difficulty level of the developers impact the understandability of APIs. So from this linker plot, you can see that this yellow bluish portion on the left hand side represent patterns, and right hand side represent anti-patterns. In most of the cases, like we have higher numbers on the left, and the patterns are quite easy to understand compared to um, anti-patterns. And we also had a figure like this. So this also reevaluates or like regenerates the effect size of different rules on the understandability, and as you can see, effect size is quite large. And this is the adjusted R square error. So for example, in here, this idea is that so if there's like negative correlation between among like pattern anti-patterns is better. So in like for 3 and 7 pattern anti-patterns, we have like negative correlation, which is a good thing, but like for the rest of the 7 we have like positive correlation, which is not a good thing in terms of understandability. And then we can just run RQ3 like that, and RQ3 will generate a similar plot as well, but it's RQ2 was about understandability, and RQ3 is about readability. So in here, in terms of readability, we can see like the R square value is the negative correlation is a little bit higher, and positive correlation is a little bit fewer, so which makes it less, which makes it better compared to understandability. And for Q3, we first generate correlation matrix and draw it. draw a correlation figure. From the correlation figure, you can see that like most of the demographic attributes like developer, student, academia, years of experience has like negative correlation, except for years of experience and Richardson maturity. So they have like they play a little bit role in like detecting pattern independence correctly, but most of the cases it does not, so it's negligible. And we also do generate p-values, and like this is candles tau. We use them, and we see like most of the cases this tau value or the estimated tau value is negative, and only for like years of experience in Canada is like positive, but which are very small. So if you like adjust the p-values with whole Fury formula, so it also reduces, so p-value also reduces. So the p-value was like for here 93.93, it reduces, so it's not that significant. So we also generated linear regression for predicting tau. That is, as you can see, the multiple r squared is also small, and the star squared is also small, and p-value is also small, so very negligible. So from all these experiments, we can see that this demographic information do not really play in like in terms of like Anderson readability. Thank you so much. And